Hello and welcome back to our maths lesson. And today we're going to continue looking at equivalent fractions, but we're going to have a look at the new learning within equivalent fractions, which actually I did hint at in our previous video, and our shortcut way of finding fractions that were equivalent. So first a little have a go before we start. So can you circle the non-unit fractions, thinking about our key vocab? What fraction of the bar is shaded in this pinky orange, and what fraction of the bar is shaded in pink, not blue, just to confuse you marginally. Have a go, pause now and give it a shot. Okay, so our answers. The non-unit fractions are any one where the denominator isn't 1. Remember, a unit fraction is a fraction that has the numerator is 1, whereas non-unit fractions has the numerator of any other number but 1. So in this case, 2/5, 4/5, and 5/6 are all non-unit fractions, whereas 1/7 and 1/9 are unit fractions. Which amount are shaded? Well, in this case, there are 1, 2, 3, 4, 5 parts. We have 2 of them, so 2/5. And then what part of the fraction is shaded? In this bottom one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So tenths. We got 4 of them, so 4/10. So that's just a recap of our key verb to do with unit fractions, non-unit fractions, and our recognition of fractions. So equivalent fractions. What does equivalent fractions mean? The word equivalent means the same as, the same value, same amount, just means the same as, equal to. So in this case, an idea of equivalent would be 2p is equivalent to a 2p piece. 2 1-penny pieces is the same as a 2p piece. They have the same value. Or we have 10 thousandths, which are the same as 1/10. Sorry, 10 hundredths, which are the same as 1/10. And this is to do with our linking to our decimals that we'll come on to later. But what you remember is in any column, if you move up one column, so from the hundredths column to the tenths column, you need 10 of the column before it to make one of that column. So we'd need 10 tens in order to make 100. So 10 tens is equivalent to 100. So here's a strip of paper. I'm going to cut it equally into 2 pieces. So like that, and split them. There's my 2 pieces of paper. Now, you could actually physically do this, but you have to make sure, remember, that your strips of paper are the same length. So if you're going to do this, take an A4 piece of paper, fold it in half, cut along it. You've got 2 strips which are identical length. Cut one exactly into half, so fold it in half and cut it along that line. The next one we're going to fold into 4 quarters. So you'd fold it in half and then fold it in half again, lengthways, and then cut along those fold lines. And what you'll see is that one of the halves is the same as 2 quarters. So you know that these are what we call equivalent. 2 quarters is the same as 1/2. So if we know that those two are equivalent, 1/2 is equivalent to 2 quarters, what do we know that we've done in order to show us that? Well, there is a couple of tricks we can do. And the first trick is this. Whatever we do to this top number to get to the bottom number, so in this case, we're timesing it by 2. If we were to have whatever the number was on top and times it by 2 and got the bottom number, then we know they would be equivalent to 1/2. And this only works with halves, but does work with any of them. So if I have a 5 on the top, times it by 2 and got 10, 5/10 is the same as 1/2. Or if I had a 4 on the top, times it by 2 and got 8 on the bottom, 4/8 is the same as 1/2. Or vice versa, you can go the other way and divide by 2. So 2 divided by 2 is 1, or 4 divided by 2 is 2. So in any way, you can find a fraction which is equivalent to 1/2 by using this pattern here. What you've done is times by 2 to get to the bottom, or divided by 2 to get back up to the top. This is what a half is. So any time that you see this, it should be a half. Here we've got a number line which goes from 0 to 1, split into quarters. And then each one of those, you'll notice, is split into half. So 1, 2, 3, 4, 5, 6, 7, 8. We have 8 of them. Of those, these 2 are the same as a quarter. So in that regard, the 2/8 is equivalent to a quarter. Here's 2/8, and that's the same as a quarter. And then if I was to do it again, I've got another section down here. Each one of these is split up as well. And what you'll notice is that the line comes down here. These ones here aren't necessarily anything to do, because see 1/8 doesn't link up here. So how many do we have here? Well, we know they're all the same, and we've actually got 20 going across here. We've got 5 here. We got that 4 times, which is 20, so 5/20ths. So 1/4 is the same as 2/8 and the same as 5/20ths. It's also the same as 3/12ths, and you can see that here. All of the lines line up down here. All of them are the same whole. It's just split up evenly into different parts. And you can see they all line up nicely. So have a think. Could you finish off this one? See if you can fill in the missing numbers for me. Okay, so this is actually just using what we were looking at before, which is that fraction wall-esque thing where we did our splitting up. What was 1/4 equal to in terms of eighths? Well, it was 2/8. In terms, if we had 3 of what was the same as a quarter, well, it was 12ths, and we had 5/20ths. And there could be more 4/16ths, and the list could go on, because you can invariably get larger and larger and larger and still find different ones. We could have 10/40ths. As long as the relationship is the same, this is a quarter of whatever this is here, then it's a quarter. So what do you notice? Have a think, have a look. Is there any patterns you can see? And this is where what we were talking about before comes in. What's the pattern between how I got from this number to this number and this number to this number? There's a few different things. First off, when we're finding a quarter, we have got a 1. We times it by 4 to get a 4, or we could divide by 4 and go back again. This is the same across the entire board. 2 times 4 is 8, 3 times 4 is 12, 5 times 4 is 20, and 10 times 4 is 40. This actually only works nicely, really, with unit fraction. It doesn't work very nicely with non-unit fractions. But you can see, or we can go the other way, dividing by 4, so 4 divided by 4 is 1, 8 divided by 4 is 2. You can see the pattern. And this works quite nicely in this way, but again, only works nicely with non-unit fractions. There is something else that you can see, and it's how we go from one number to the next. So whatever we've done to our numerator, if we times it by 2, we have to times the denominator by 2 as well. So 1 times 2 is 2, 4 times 2 is 8. So 2/8 is the same as 1/4. Or if we were timesing 1 by 3 to get to 3, we have to times the bottom by 3, the 4 by 3 to get 12, and it's still an equivalent fraction. The same if we times by 5, by 4, by 10. As long as we do the same to the top as we do to the bottom, it can be timesing. We could go the other way as well. So say if we had this 10/40ths, and I wanted to get down to here again, I could divide by 10. But if I was doing that, I'd have to make sure I divided the bottom by 10 as well in order to get back again. So depending what you want to do, but you're doing the same here as you were doing here. And that's the important thing. Whatever you do to the top number, you must do to the bottom number, and whatever you do to the bottom number must be done to the top number. If you do the same thing to both parts of the fraction must be the same, must be equivalent, depending on how you cut it up, but they will always be the same. So have a look at this one. We've got 3/4, we've got 12 somethings. What have we done to 3 to get to 12? What we've done is times by 4. So what that means is we must do to the 4, the denominator, we must also times it by 4. Do the same to the top as we do to the bottom. 4 times 4 is 16. So these fractions are therefore equivalent. And this trick is amazing because we can use it to simplify fractions, to go from fractions which are really complicated, like 10/40ths, and we can take it all the way down to nice simple fractions that are easy to understand, like a quarter. So here are my 3/4, and I'm going to split all of them into 4 because I'm timesing by 4. So there it is. And then you can see, there we have 12/16. And that's what we're trying to talk, that's what we're doing when we're saying, oh, we're timesing by 4. We're actually splitting each of our quarters into 4 parts to get 16 in total, of which we have 12. Have a look at these ones. Have a shot. Go give it a try. And I'll pause now. Okay, so we've got to remember our rule, what we are doing in order to get to the answer. So in the top case, we're timesing the denominator by 3, which means we must times the 3 by 3 as well, which gives us 9. Now, this bottom one's slightly more interesting because what we're doing, we're missing this part here. So I can't times because I'm timesing from something I don't know. So we work the other way. If we're dividing by 3, that's a relationship between 5 and 15. Times 3 one way, divide by 3 the other way. You can always think about it in the other way. So if you go, okay, I don't know this one, but in order to get from here to here, I have to times by 3. That means to go backwards, it's dividing by 3 because you know the inverse. That means that to go from here to there, we also have to divide by 3. In order to divide by 3, 9 divided by 3, or 3 times something equals 9, the answer is 3. So 3/5 is the same as 9/15. Using that and what we've just talked about, have a go at these ones. Pause now. Don't be scared to have a go. Think it through. If you get stuck on a question, have a look back at what we've spoken about. Think about our rule. Whatever we do to the top number, we must do to the bottom. Whatever we do to the denominator, we do to the numerator. Whichever way around it is, as long as we do the same thing to each part of our fractions will be equivalent. So my top tip, do the same to the bottom as you do to the top. Have a go, see what you can do. Pause now. Okay, so let's have a look. So the first one says, shade the shapes to show you equivalent fractions. And so we've got, it says shade 1/4, there it is, shade 3/12, we've got the same amount shaded. 3/4 is 9/12, 1/6 is 2/12, and 5/6 is 10/12. Then it says draw 2 rectangles that show 1/3 is equal to 4/12. So the easiest way to actually do this is after you've drawn one, so you would draw one, draw the other one exactly the same way. So you draw it exactly the same as you did the first one, shade it in, and then to get from 3 to 12, you have to divide by 4. So you need to split this into 4. So 1, 2, 3, 1, 2, 3, 4. There's your 4/12 because there's 12 overall. And that's the way I think about doing it. Just makes my life slightly easier. Number 3 is sort these fractions into groups. So which one of them equivalent to 1/4, which one's equivalent to 1/3, and you just take these, check them against which ones they're equivalent to, and put them into their parts. So this is how they're split up, and then obviously you can think of another one that you could try and put into each one if you like. Then this says complete the fraction equivalence. So what you're looking at is what you've done to 2 to get to 14, which is times by 2. Which means you'd have to times by 2 on the top there as well. Times by 2. So we've got to times the top by 2. This one, we've done times it by 2 here. So we must times the bottom by 2. This one, we've times by 2. So we've got to times by 2. This one, we've times by 4. So you have to times here by 4 as well. You get the pattern. Whatever we do to the top, we must do to the bottom. Times by 3, times by 3, times by 5, 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 times by 5. And that's the pattern. That's the easiest way to think about it. Do the same to the top as you do to the bottom. The pattern on G, H, and I are all times in by 5 in order to find it. That's how we find the equivalent fractions. Here's our next thing. So W here says, I've added 6 to both the numerator and the denominator, therefore they must be equivalent. Is he right? And of course, let's have a look. 2/3, we've got that there. Let's make ninths, there they are. And there's only 6 there. If we were to shade in 8, we would shade all of those as well, and therefore they definitely aren't equivalent. So the equivalent fraction would actually be, we have to times this one by 3. We have to times the top by 3. 2 times 3 is 6. And you can see that with our diagram down here as well. So in this case, have a think. What's the problem and what could we do to solve it? Well, the problem is there's no easy way to get from 12 to 40 or back again. So we'll ignore this one for the moment and work instead with 15 to 5. What did we do to get from 15 to 5? We divided by 3, which means we must divide 12 by 3 to get to the top over that side. 12 divided by 3 is 4. Now we can think about the relationship between 4 and 40 because there's an easy one there. We know that we can times by 10, which means we have to do the same to the bottom, which is timesing by 10 to find that bottom one, which means it's 50ths. All of these are equivalent because we've done the same to the top as we've done to the bottom. We don't need to worry that we jumped over this one because all of them are equal to each other, which is why we've got the equal sign between all of them. So we could think about this one in relation to this one before we came back to that middle one. And that's why it works in that regard. And as long as we do the same to the top as we do to the bottom, we'll still get to that answer. So have a go at these ones. Just remember that top tip. Do the same to the top as you do to the bottom. Off we go. Okay, here's your answers. So number 5 is interesting. I'll talk it through before we go on to the answers. What you have to think about is what you've done here. So we've done timesing by 7 here. So any number you put down here, so if it was a 2, 3 and a 4, for example, as long as we times that by 7 in each case, then we get the right answer. So that'd be 14, this would be 21, and this would be 28. And as long as we can do patterns. Same with this one, what we actually done here, we timed it by 2. Now we can have 7 sevenths, and then we know that's 14. They're the same. If we had that as 8s, we times it by 2, so it'd be 16ths. And if we put 9ths here, this would be 18. You could have any numbers you liked as long as you've times by 2 to get between them. What have we done here? Well, this is timesing by 2. So I could put a 1 up here, times it by 2 to get 2. I could put a 2 up here and get a 4. And I could put 3 up here and get a 6, because what I'm doing is having to times by 2 in each case. Okay, so the answer to number 6, Ron is finding the equivalent fractions of a quarter. A quarter is equivalent to 5/8 and 9/12 is what he's saying. Well, do you agree with him? Draw a diagram to support it. So you would just draw out those, and you can see straight away that they aren't the same. Literally because there's more of the shape filled up in each case, they definitely can't be equivalent. Here are some equivalent fractions. Find the values of A, B, and C. They put A, B, and C here. So what you're doing is just trying to find the links between them. What have you done to one to get to the other? Well, for C, you times 9 by 10. So you'd have to do the same here. We can't find that yet. So we have to use the one we know, which is 2/18. What have we done to get from 18 to 9? We've divided by 2, which means we would need to divide by 2 here, so that would be a 1. Then we can think about what we've done here. What we've done here, times it by 3 to get from 1 to 3. Well, then 9 times 3 is 27, so that would be 27. You times by 10 to get there, so times by 10 there, so that would be 10. And that's how you get the answer. You have to use one that you know the entirety of in order to start you off. That's the trick to ones like this. Here's 3 fraction cards. Here they are again. All of them are equivalent. A and B, this one and this one are 13. Can you work out what C would be? Well, A and B are 13, gives us a little hint, but we'd have to then work out what they would be in order to find that. So yeah, think about what the relationship between them is. So it's got to be a number that can be times to get something by 14. So a number we definitely know is 7. We can times it by 2 to get 14. What would then be left over? So 13 minus that 7 is 6. 6 would be there if that's true. Let's just check it. 7 times 2 is 14. Yes. 3 times 2 is 6. Yes. So we're all good. Then we can think about, okay, now I can use that understanding to go from 3 to 12 is timesing by 4. So I must times 7 by 4 to get C. So C is 28. And then finally, I've got 1/5 is equal to 3 over 1 plus something. So what have I done to 1 to get to 3? Well, I've times by 3. So I've got to times 5 by 3 to get this. So 5 times 3 equals 1 plus my blob. So what does 5 times 3? 15. 15 is 1 plus my blob. So 15, I need a number that plus by 1 is equal to 15. It must be 14. And there's our answer. Thank you for that. I hope that makes sense. You can always go back and look at it again. But just take your time, think about it logically. Remember the top tip. Whatever you do to the top, you do to the bottom. Thank you, and I'll see you in the next video.